is the Vice President of Cloud and Enterprise Security at Microsoft. Over the last 2 decades, he's worked to improve the security of Microsoft customers' products and services. He built a security research group to further security science and improve the resiliency of products, contributing changes to Windows, Internet Explorer, and compilers, and various online services. He was a founding member of the Microsoft Security Response Center, which monthly sends updates to protect over 1 billion customers around the world. Currently, he oversees data center security services for Azure, online services used in Office 365 to protect customers from mail-based attacks, and centralized threat intelligence for the company. Matt, please.
All right, good morning. So we heard some of the challenges that were put forward, and I think I'm going to talk about a couple of them. Of course, we'll have a little bit more in the panel discussion later. But today, to start, I want to talk about innovation in defense. And when I say innovation in defense, I mean broadly. How do we make sure that as we have an innovation, we can actually roll it out and get it so that it is the fabric of the internet, the fabric of cyberspace? And for that, I call that persistent security. It's everywhere. I've seen a lot of proposals over the years, a lot of ideas, a lot of technologies, a lot of startups pitching ideas about how to secure the platform. And I've seen some common failure modes for some of those ideas. So I want to make sure we highlight those. And I think that talks to what sort of innovation we need and what sort of problems we need to solve when we're thinking about new technologies and innovation. But first, I want to talk about the opportunity. The question was, do we have too much innovation? I think it's hard to argue, you saw some of these data points earlier, I think it's hard to argue that we have just the amount of innovation we need today, that we've solved the problems. First, the problem space that we're trying to solve for is changing. It's not static. 50 billion devices will comprise the internet, will comprise cyberspace by the year 2020. Data volumes are surging. All of these devices are going to emit and consume more information. CIOs are looking how to move their enterprises to the cloud, take advantage of that. Platforms are changing. It's getting harder for enterprises to go contain and manage the systems that they've got. I think there's a big change here, and I think that's a challenge for us. And attackers, they're not static either, right? We've seen over the last few years that it's not just about single vulnerabilities, it's about cross-industry vulnerabilities. So when a vulnerability comes out, it's Apple, it's Google, it's Microsoft, it's others, all responding on the same time frame to try and close these issues. We're also seeing attackers go up and down the stack. We're seeing them go after hardware so they can persist. We're seeing them go up the stack into kind of the logical layer to worry about trust anchors, things like root CAs on the internet that are being taken over, and those trusts are being abused. That's a different sort of paradigm than we've seen in the past. We've seen destructive attacks, we've seen the APT, the slow and low attacks. That's different. And of course, we've got nations investing in offensive capability and bringing the might of leading militaries to bear against commercial entities. So attacker trends are also concerning. And that's really capturing the attention of industry. It's capturing the attention of CIOs, of CEOs, it's boardroom conversations. Nobody wants to be the next, pick your company, the next Sony. And so that's driving investment in this area and the interest in this area. So I think I've made the case where there's room for, there's need for, and there's a market for new defensive capabilities. In my work, I've seen a lot of solutions presented, but I'm most interested in solutions that can be adopted broadly, and I call that mega scale. How can we make sure that when we do have an innovation, we can roll it out, in Microsoft's case, to hundreds of millions or billions of endpoints or billions of consumers? Historically, our focus has been on protection. We worried about how we would keep adversaries out. And in the case, if you looked 5-10 years ago, it was really about how do we keep cyber criminals from going after consumers? How do we keep them from going after enterprises? We use things like economic models to go put pressure on the cybercrime ROI. How do we make sure that their investment cycles are longer? How do we make sure they're more expensive? And how do we make sure that they only get to use it a few number of times before it's taken away from them? That was reasonably successful, actually, against cyber criminals. You can look at the rates of attacks and the success of attacks against consumers, and it's step change from where we were a decade ago. But things are changing. As I said, the types of systems people are using, the platform diversity, the edge disappearing is all forcing us to go look at the other areas of this circle. The detection. How do we detect at scale? How do we respond? How do we recover? And that's going to require us to do more in innovating in those areas. Let me give you a few examples of some of the past innovations that have worked in the Protect cycle and talk about why they've worked. So we've innovated in the platform at scale over the last 10 to 12 years in some pretty significant ways. These are some of the more recent things that we've put forward. And a lot of them you may not even realize are being deployed, and that's kind of the point. So trusted platform module, protection down in the hardware. So UEFI, making sure that we can secure the boot. That actually gives us, those two things give us a platform so we can do things like measured boot and secure boot. It's built into Windows today. You might not even know it, but if you buy a consumer PC today, you've actually got secure boot with Windows 8. Exploit mitigations. We've put exploit mitigations into Windows since Windows Vista. This makes it harder, even if there is a vulnerability, for an attacker to go leverage that vulnerability. We can do that without the consumer, without my parents having to know it's there, having to know that layer of protection is increasing the costs for attackers. Most recently, we're deploying something called Control Flow Guard, which will take it to the next level. That will come out in Windows 10. The scourge of passwords. How do we get to two-factor? How do we get to biometrics? We know we need to get there. We've made some significant progress, I think, over the past few years. We're going to make some steps there going forward. That's a particularly interesting one because we know we need to do it, but there's some friction involved. I'll get to why that's important. And then application stores. Why do I put that up there as a security innovation? Well, it was a big pain point. And application stores, the rise of application stores, gave us a way to go manage the entire application lifecycle in a way that we didn't have the capability to do before. We can actually keep applications up to date. We can actually curate them before they get into consumer store, consumer marketplace. And so these things allowed us greater ability to control the experience in a way that we didn't have before. We have another step change coming as we look to the cloud. And so, when people think of moving to cloud, the common things we think of, the hygiene things. Small companies, small or medium business today struggles with things like patching or monitoring or access control. Think about the local furniture store. How do they deal with managing their IT on a daily basis? Well, it's one PC sitting in the back room. Is it up to date? Is it managed? Probably not. Or at least probably not to the level at which we can do in the cloud for them. And so those are very important basics we can do. But I think there are whole areas of innovation that are going to come online and give the small furniture store the advantages of the Fortune 10 today. So some of those are everyone gets to leverage the expertise, the relationships, the threat intelligence that we've built over the years. And so the assets that Microsoft has, the relationships with many of the companies in this room, where we get information that we can go act on to protect 1 billion customers. We get that and we can act upon it for that furniture store automatically. The second one is cross-company detection and mitigation. If you're running your own Exchange server, you might detect a phishing attack and you might be able to go back in and make sure it doesn't hit you again. If you do it across many customers, as we do in the cloud, we see one phishing attack against one customer, we can protect all customers. And so we get that level of scale, that multiplication. There are more technologies and more techniques we can use that idea across. And then finally, everybody has access to advanced capabilities. So in the past, how many people had the ability to do things like process big data or have access to massive compute or storage or ML, machine learning? Well, today you can. Right? You pay a couple of dollars, you get an account, and you have all these tools available to you. So I think those are some of the modes that are going to change the game in cloud. So when we think about what the innovation space looks like, I think this is an important thing to keep in mind. So why do some of these innovations over the years succeed? And what sort of barriers do we have to overcome to see them succeed at scale? I've put together a list of some of the common failure modes, what I call the 8 great barriers to getting defensive technologies to succeed at scale. You'll look at these, and a number of these you'll say, well, that's pretty obvious. But in fact, I have examples, counterexamples that I'll walk through that show, even for large companies, we've failed at some of these. So the first one, there are solution barriers. There are 3, I'm going to talk about solution barriers, customer barriers, consumer barriers, and barriers to the enterprise adoption. So first, solution barriers. The first one is, your solution has to survive the first encounter with the enemy. You have to be resilient to the next round of attack or innovation. If you stop what's out there today, that's great. They've got an investment loop, and as we heard before, we've got a deployment cycle that consumers, that enterprises are on. We need to make sure that the barriers that we're putting in place are going to be resilient. If you've got a niche product, it might work just fine, but as soon as you deploy something 1 million or 1 billion times, it's going to be targeted, it's going to be worked around. The second is protection and detection must be effective, it must be high signal, it must be actionable. That means things like high distinction, high discrimination. It also means things like driving down false positive, false negatives. If you don't do that in real usage, and that's the key, then it's going to be too noisy to use, too noisy to deploy. Consumer barriers. First one is you have to get it into the customer's hands. You have to get it into their hands at scale. And at scale, it needs to be in their hands by default. So we learned this one the hard way. A famous example would be Windows Update. So Windows Update was one of the things that in Windows XP Service Pack 2 was on by default. That was one of the big, if you think about the big things we delivered in Windows XP SP2, it was the firewall on by default, and it was Windows Update on by default. Windows Update existed long before XP Service Pack 2. But that was the time when we actually turned it on by default, because we found that people weren't finding it to go flip it on and update for themselves. So the simple act of turning that on by default, making sure we had default protections in place was actually very important. Contrast that against some of the technologies that we have today, the protection technologies we have today, where we've iterated enough on the solution where we can just turn them on by default. Reference ASLR or the secure boot example I used earlier. It's just on by default. You don't have to know. I don't have to tell my parents to go in and configure something. Next one is you can't impede consumer usage. If you do, they'll turn it off, or they won't adopt your technology. Examples here are things like ad blocking. I've got a great ad blocker, but it turns out if there's an embedded YouTube clip, it won't run. Well, guess what? That won't be used. We've also hit this in the early days with the firewall. One of the reasons we didn't turn the firewall on by default in Windows XP was we were worried about consumer usage. We were worried about applications that wouldn't work correctly and consumers would reject the idea that the firewall should be on. And so it took us more time to actually go get that right and get it on by default. And the last one is you've got to do things that automatically protect and don't involve user decision making. User decision making is notoriously poor. That's not because users are dumb, that's because it's difficult and the bad guys are going to try and game that. And that's what phishing is all about, it's trying to trick the user. So if you're asking them a security critical question, they probably don't have the context necessary to answer that correctly 100% of the time. So we need to get better about doing things with reputation, with crowdsourcing, with being able to make decisions automatically for them. On the enterprise, there are a few barriers as well that are separate from consumer barriers. The first is, do no harm. These folks are struggling to go contain the systems they've got. They've got legacy systems, era 2000 systems, they've got partners, they've got relationships they have to deal with, they've got line of business apps on their hands they're trying to get rid of or move forward, they're trying to onboard onto the cloud. Adding more cognitive load to the enterprise admin is a non-starter. Second is it has to be manageable and flexible. Adding another pane of glass increases cognitive load, see point 6. But other things, you're never going to anticipate their entire usage scenarios. I've been astounded by some of the conversations I've had with customers. I've had my technology, things that I've written. I've had conversations with governments, with militaries, about how they work because they're worried about how they can use that technology in the battlefield to communicate between tanks and make sure they can actually revoke a tank should it be overrun. That's not something I designed for, but it needs to be manageable and configurable to the point where they could actually use it in those scenarios. Another example is oil rigs. Using Windows software in oil rigs and thinking about replication delays. These things are important, and it's hard to do at scale. And finally, scale down and scale up. When we deploy something in like Windows Server, we're not only serving the Windows enterprise, the Fortune 500, the financials, who might have high availability clusters and large numbers of admins and machines. We're also focused on the single server under the desk, the furniture store. And so how do you make sure that your solution can scale to both of those ends? So with that, I think I'm going to leave it, and thank you. I look forward to seeing more of your solutions satisfy these, take these into account so we can see more of these defensive solutions deployed at scale.